today we're going to do indices. I've got Ben on camera again, and he's going to put the camera into the cradle so we can show you some examples. Where's the thing? That's not working too good. Okay, that should be okay. All right, so if I have y to the power of a times by y to the power of b, that's going to equal y to the power of a plus b. That looks very confusing when you see it like that, but it's so much easier when it's explained. So to multiply powers together, you add your indices. That's what it's saying. If I had y to the power of a divided by y to the power of b, that would equal y to the power of a minus b. If I had y, let's move that up. If I had y to the power of a all to the power of b, that will equal y to the power of a times b. So that looks, I think that looks quite confusing, but when you see it with numbers, it sort of explains itself. So for example, with this one, if I give you an example of that next to it, if I had 3 I just don't know if you can see it. I'm hoping you can. If I have 3 squared times by 3 to the power of 4, my answer is going to be, well, looking at this, my base number stays the same, so keep my base number the same. And my indices, I added them together, so this is going to give me 3 to the power of 6. So my base number stays as 3, and then I add my indices together. So looking at how they match, I've got y to the power of a times by y to the power of b. So I end up with y to the power of a plus b. So when this was numbers, I got 3 squared times by 3 to the power of 4. So that gives me 3 to the power of 6. I just add my indices. If I have here, I have 5 to the power of 6 divided by 5 to the power of 3. Looking at how this matches, my y stays the same there, so my base number is going to still be 5. And then I take my indices away, because here when my powers were a and b, I took a, I did a take away b. So I end up with 6 take away 3 gives me 3. So 5 to the power of 6 divided by 5 to the power of 3 equals 5 to the power of 3, because I'm taking those away. And with this one, if I had I had y to the power of a, all in brackets, and then to the power of b, all of it to the power of b. I end up multiplying. I have y to the power of a times b. So giving you an example of that if I had 2 to the power of 3, all squared, that would give me 2 to the power of 6, because I just multiply those together. My base stays the same, and I multiply these together. My base stays the same, and I multiply these together to give me 6. So I'll do some examples to help you see. So if I had 2 to the power of 2 times by 2 to the power of 7, that is going to give me, base number stayed the same, 2 to the power of, I add my indices because I'm multiplying my base numbers. So that gives me 2 to the power of 9. If I have 5 to the power of 2 times by 5 to the power of 5, my base number stays the same. So it gives me 5, and then I add my indices, 5 to the power of 7. One more of those. 6 to the 5 times by 6 squared. That will give me, my base number stays the same, 6 to the power of 7. I'll give you some examples with division. So here I've got 3 to the power of 8 divided by 3 to the power of 4. Now this time I'm dividing, so I keep my base number the same and I take my powers away. So that's going to give me 8 take away 4, which gives me 4. So 3 to the power of 8 divided by 3 to the power of 4. My base number stays the same, and then I take these two numbers away to give me that. Now I've got 8 to the power of 9 divided by 8 to the power of 4. My base number stays the same, and I'm left with taking these away. 9 take away 4 gives me 5. If I had 2 to the power of 14 divided by 2 to the power of 7, my base number stays the same, and because I'm dividing, I take these away from each other, so that gives me 2 to the power, why did I write 7 there? 2 to the power of 7. And last one of those, because it's going to be a negative one I want to show you. So I've got 6 to the power of 4 divided by 6 to the power of 8. So my base number stays the same, and then I do 4 take away 8, so that's going to give me negative 4, and that is fine. It's kind of feels a bit odd writing a negative number there, but it's fine. Okay, and then the final one we did earlier on, if I had 5 to the power of 4, all in brackets, to the power of 6, that would give me, my base number stays the same, and then I multiply these together, so 6 4s are 24. If I had 3 to the power of 3, all to the power of 7, my base number stays the same, and then I multiply those together, 3 7s are 21. 8 to the power of 2, all to the power of 8, my base stays the same, 2 8s are 16. And I've got another one with a negative just to show you how that works. So I've got 7 to the power of 4 in brackets to the power of minus 2. Well, my base number is still going to be 7, and then I multiply these together. So I've got 4 times minus 2. Well, 4 2s are 8, and because it's a negative times a positive number, that's going to give me negative 8. So 7 to the power of negative 8. Okay. Now we're going to do slightly more tricky ones. If I can just get my piece of paper in the right place. So I'm going to have 3x to the power of 5 times x to the power of 2. So remember, when you've got x to x squared, it's basically 1x squared. That's not ever put there, but it is. That's what it means. So my normal numbers, my regular numbers, I'm going to treat them as normal. So I'm going 3 times 1, well, that gives me 3. And then I'm going to add my indices. So 5 plus 2 gives me 7. And the reason I'm adding them is because I'm multiplying my numbers, my regular numbers. So this is going to give me 3x to the power of 7. Now we've put some unknowns in here, so some x's in there. Another one, so we've got 5y squared times y to the 5th. So again, you could think of that idea of having a 1 in there. So dealing with my numbers first, once 5 is 5, and then I've got y squared times by y to the power of 5. So I'm going to have y, and then I add my indices together to give me y to the 7. Because I'm multiplying here. If I have 4x squared times by 3x to the 6th, I treat my normal numbers as I normally would do. So 3 4s are 12, and I've got x squared times by x to the 6th. Because I'm multiplying them, I then add my indices, so 6, 7, 8. So it's going to be 12x to the power of 8. Another one, so I've got 2x to the power of 4 times by 5x to the power of 7. So again, treat my numbers like I would normally. So 2 times 5 is 10. I'm multiplying together, so I've got x to the power of 4 times by x to the power of 7. So because I'm multiplying, I add these, so 7, 8, 9, 10, 11. It's going to give me x to the power of 11. And I've got 5x to the power of 5 times by 6x to the power of 6. Treat my normal numbers like I would, so 6 5s are 30. X to the power of 5 times x to the power of 6 is going to be x to the power of, I'm adding my indices, so x to the power of 11. So these numbers I just treat like I normally would. So 6 times 5 is 30. Once I've dealt with them, put that down there, I just can concentrate on this part. So the x to the power of 6 times by x to the power of 5. So I'm left with x to the power, and to find out my power, I add them together. Right, last one. So I've got, move that across, 4y, oh no, this is different actually, sorry. We've got 4s cubed times by 3t to the power of 4. Now this is one you could easily get wrong actually, because these are different. So we treat our normal numbers like we would do normally. So 4 times 3, so 3 4s are 12. I can't actually do anything with these indices because these base numbers are different. So I just have to do s to the 3, t to the 4, because they're not the same base. On all of these other ones we've done so far, these base letters have been the same. So we've had x squared times by x to the 6. So we've just added our indices. We had y squared times by y to the 5th. So we added our indices. This one, it was s cubed times by t to the 4. So we can't do anything with that. We can't add them because it's s cubed and t 4. So we keep that as it is. Okay, then we have ones with division. So for example, we have 10y to the 6 divided by 5y squared. Well, earlier on we learnt that when you're dividing your normal numbers, you subtract your indices. So we treat our normal numbers like we would normally. So we've got 10 divided by 5. That's going to give us 2. And then here we've got y to the 6 divided by y squared. So our base is the same, so y. And then we take these away. So 4 take away 2. 6 take away 2 gives me 4. And another one, so we've got 6x to the power of 9 divided by 3x to the power of 3. So again, treat our normal numbers like we would normally. So 6 divided by 3 gives me 2. And then again, these are matching, so we can take our indices away. So we've got 9 take away 3 gives me 6. So we did 6 divided by 3 to give me that 2. And then our base was the same. I've left my base off there. 2x to the 6. Our base is the same, and then we take our indices away. So we end up with 9 take away 3, which gives me 6. There. I think I'm being a bit scatty today, but hopefully it's making sense. Now we've got another one, so we've got 20x to the power of 7 divided by 4x to the power of 3. So again, we've got our normal numbers, so how many 4s go into 20? Well, 5 4s are 20, so our number is going to be 5. Our base is going to still be x, because that's the same. And then we're dividing, so 7 take away 3 gives us 4. So 5x to the power of 4. Another one of those, so we've got 18x to the power of 8 divided by 6x to the power of 3. So 18 divided by 6, or 6 3s are 18, so it's going to be 3. My base is x, so that stays the same. We're dividing here, so we take these away. So 8 take away 3 gives me 5. So recapping, when we had these ones, we multiplied our normal numbers. So 4 times 3 gave me 12. And because we were multiplying here, we added our indices. These ones down here, we had 18x to the power of 8 divided by 6x to the power of 3. So I treat my normal numbers, I do whatever this is telling me. So 18 divided by 6 gives me 3. My base is the same and I'm being told to divide here. So I have to take those away from each other, take my indices away from each other. So 8 take away 3 gives me 5. And I've got one more of those. So we've got 35x to the power of 10 divided by 7x to the power of 4. So 35 divided by 7, well 7 5s are 35, so that's going to be 5. This, my base is x, they match, so we can put that there. And since we're dividing, we do 10 take away 4, which gives me 6. So 35x to the power of 10 divided by 7x to the power of 4 will give me 5x to the power of 6, taking those away from one another. Okay, and then if I had, oh yeah, we'll do down to there, I think, with these. That there. If I had a cubed all to the power of 2, going back to what we did earlier, we just multiply these together. So that would give me a to the power of 2 times 3 is 6. If I had y squared to the power of 6, I multiply these together. That gives me y to the power of 12. One more of those. A cubed to the power of 7, that would give me a to the power of 3 7s are 21. Now there's ones which I used to find more complicated when I was younger, and those are ones that have brackets and then a number here. So 2a to the power of 3 all squared. Now the reason it's easy to get into a muddle with these is because this square is acting on this number here as well. It was also acting on this one here, but since once 1 to the power of 7 is still 1, it makes no difference. You still end up with 1 here, because 1 times 1 times 1 times 1 times 1, like however many times, is still 1. Whereas this one, this squared, is acting on that 2. So I've got 2 squared. So this is going to give me 4a to the power of, and then 2 3s are 6. If I had 3y squared in brackets to the power of 6, this power is acting on the 3. So it's actually 3, I'll move that along so you can see, 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5 times 3, which equals 729. So this, because this 6 is acting on, this power of 6 is acting on this 3, that's going to give me 729 y to the power, and then I multiply those together, 2 6s are 12. Another one of those. So they're deceptively tricky, those ones, because you have to remember this bit that's acting on that. So we've got 5x cubed, all in brackets, to the power of 2. So again, this squared is acting on this 5, so 5 5s are 25. 25x to the power of, multiply those together, 6. And last one of those, so we've got 6x to the 7 all to the power of 3. Well, again, this cube here is acting on that, so that's 6 times 6 times 6. 6 sixes are 36, and 36 times 6 is 216, so it's going to give me 216 x to the power of 3 sevens are 21. And I'll just do one other little thing actually before I finish, I think. Yeah, I've got ones with negative numbers, just a couple of easy ones with those. So you might have y to the minus 5 times by y to the 7. So these are simpler again because they're just multiplying together. So we're going to add our indices. So we've got minus 5 add 7. Do you want to have a go at that, Ben? Can you think what minus 5 plus 7? Very good. So that's going to give us y squared. So these, try not to overthink it. Just think of it as a number line. So you're sitting on minus 5 and you're adding on 7. So that's going to give you the power of 2. Give you one more of those. You've got x squared times by x to the minus 4. So my base is the same, x. So I'm going to do 2, and I'm adding them together. So 2 plus negative 4. So 2 plus negative 4, that's going to give me negative 2. And if I had if I do x to the minus 2 divided by x to the 4, well, this time, because I'm dividing, I have to take away. So my base is the same, so it's going to be x. I do 2 minus 2, take away 4, so that's going to give me minus 6. And I think that's everything. Hope you enjoyed it.